So today we're doing Leetcode at the airport 310 minimum height trees. So basically height of trees longest path from root to any of the leaves. And what we want to find, so minimum height tree means that if we pick all nodes as roots, then we get their heights. And then minimum height trees are those that have the smallest height, and we should return their roots. Now the thing is that, okay, let's say we calculate height of each subtree, and now when we recurse, can we somehow use the information? Well, we started the root, and then this is more complicated. So we started the root, right? Then we move here. We have height here, and then height of this thing is 1 plus maximum height of this, right? And that's it, I guess. So first we find the heights, and is the number of edges, okay. Should be 1 times n, dfs 1 n. List. Okay, and then in HV, if U is not P, then height U plus is equal to height A plus 1, and then we run DFS from there. And this is the whole DFS. I just changed the name of this. We run the DFS from 0, and then after we have done that, here's what we need to do. We store let's store ans, right? And then in ans we'll store pairs of vertex, which is the root, and then height of the tree. So let's say v parent and parent height. And then first we need to get heights of children. So child heights for u in HV. If you don't equal P, and child heights append height U. So we have done that, and then we need like suffix height for U in HV, for I in range, len suff height minus 1 minus 1 minus 1, suff height I is child height I, if I plus 1 is less than len suff height, then suff height I max suff height I plus 1. Basically what I'm doing, because I want all but one child, so prefix I can have let it be 0, and then for I in range len SUV height, or I do like I0 for you in HV. The ans for here should be ans append V max P height and height V. That's fair. Then we call DFS to B minus 1, 0, and then mean index. Final ans is this, or let's do it like max height, like mean height is, I don't know, like n plus 1, right? And then we go for vertex height in ans, if height less than mean heights, then mean heights is equal to height, and final ans is this, and then if h is mean height, ans append vertex. So basically I just iterate, this is constructing answers, I iterate over all answers. If its height is less, okay, I reset values and then I add to answer, and now here I'm missing doing the DFS. So if u is not b, then what do we do? And then we do like prefix height, so everything but that child plus the suffix, so new p height is equal to max prefix and then 0 if I plus 1 is SUV height, else SUV height I plus 1, DFS UV new parent height plus 1, not really parent height, it's just this. Yeah, so it's just oh no, that's good. Okay, new parent height, and then we do what? I plus equals 1, ref max ref SUV height I, like this. That's so stupid. I'm not sure this will work at all. Mean height, let's see. Wrong answer. So ans 0, 1. Okay. That is weird, bruh. Going to be parent 0 minus 1 if u is not parent. Oh, I'm not constructing for xy in trace, match, append. Okay, this should work. DFS is not defined. Where? Here. Let's see. Int is not iterable. What the freak? How come? That's weird. Ah, that's a function. VP height. Should be +1, I guess.
Ja.
Suffix heights for each vertex. If we don't actually want to free frame. What the hell? Nah, bro. Nah. Height V is height U. Max height V plus height U plus. Let's see. That is now correct. 0 has just a single child. One, 0, 1. What's the answer? What's the answer? So they should start from 0. Confused. That's weird. 1, 0, 1, and then how is that? I don't understand this, bro. Something is wrong with this shit. 1 0 0. The fucking bad guys are shit. Let's see. It's like prefix. That's weird. Why is it not 2 though? New parent height. It should be max of parent height. New parent height. I am fucking lost with it. So from B to U it should be like this. Oh, great, now it's dying. 101. Oh, now it works. That's crazy. Wait. Print. Oh. Please tell me it works. Oh my god, the second case doesn't work at all. I have to return them one indexed? You kidding? And this is what? No. No, why am I submitting? 0 free. Okay, from free is just 2. From 1 it should be free again. Because let's imagine it going from 0. So it goes 0 free and then all those guys. Maybe it should be +1. I don't know. So from 3 to 1. From parent going it's 1. From here it should not be 1 for sure, bro, because v suffix height. That's weird. He's going 1 to 4. What is that? Print height. Height is 3, 0, 0, 2, 1, 0. So this should be at height 2, right? One. The vertex itself is 1. So it should be plus. Then I got 1 from parent. So it should be plus 2. That cannot be right, bro. That cannot be right. Nah, that's not correct. Oh my days. Where can I pause this shit? What's wrong, ref? I mean, plastic can be right, but then this is height 2. So then we have to increase this to 1 and start with height 1. What the hell? Okay, I mean that worked, but this didn't work again. So it's 0 from here, but why is it 1 from 3? What the hell? So 3 to 1, and then from parent we get 2, but why do we get only 3 from here? Because we should get, like for its other children, the suffix height is 2 to 2. So I guess it should be this plus 1. No. Plus 1 here. No, submit it again. But 39 passing. Three, 1, 3, 2. So then we get 1, 3, and parent height is 4. So 4, output 3, but 4 should also be an output. How come? So let's see, 3 going to 4. Let's see, DFSD parent height, new parent height. So go from 3 to 4. And what new pair now is what? What the hell? Maybe I should have also print prefix, and then this part too. And let's see what happens. 3 to 4. So prefix is somehow 2. Not suf height. Should just be child height. Child heights. No way. Okay, let's comment this out. Let's comment this out and this. And here is a print. And here is a print. Okay, nothing printed, let's run it. No way. It went through, that's crazy. DFS. Okay. Rerouting DFS, so intuition. First we calculate the height of. First we route the 3 in vertex 0 and then calculate height of each subtree in height v. Then we run a second DFSO to get heights of all rooted trees. We have to use the information computed in height to recalculate height for each new root based on its subtree height and the rest of the tree. How can we do that? Approach. We run another DFS. We just have to realize that height of the rest of the tree is the maximum height of any other child's Okay, suppose we are in vertex V and want to calculate height by rerouting in child U. We just did height of rest of the tree except for subtree U is the maximum any other child of V subtree plus 1 for V itself. We calculate maximum height among other children. We just calculate prefix and suffix child height, and then we can take maximum of prefix and suffix child height excluding the current child, which we can calculate in O1. Iterating over all edges of each vertex twice, but that's still in total OM, where M is the number of edges, which is ON, since we have a 3, so the ON, since we first constructed the adjacency list, but there is ON edges in OM, where M is the number of edges, but there are ON edges. Since we have a 3, then in the second DFS, but it's still in total OM iterations, where M is number of edges, which, as already said, is only ON since we have a 3. Finally, we just go through all nodes and check heights of the tree if it were rooted in that vertex, and check if it has the, so it goes here, has the smallest height. Finally, in ON, we just find the roots with smallest heights. Space complexity ON. Since we have a Since we have a tree which we store in an adjacency list, and what? Maybe I should remove these print statements. Let's see. Let's remove these. Let's remove these, and then let's remove these. Okay, that's it. And we have a few auxiliary arrays of length ON. That's fair. Let's post and see you tomorrow, hopefully. Goodbye.